Hi everyone, in this video we'll talk about Bitwise module in TensorFlow. So let's get started. As you can see here, there are several functions inside Bitwise module. The first one, Bitwise and Function. The second one, Bitwise OR function. The third one, Bitwise XOR function. And the last one, invert function. Let's first talk about Bitwise and Function. This function has three arguments, x, y, and name. This function computes the bitwise AND of x and y. Let's take an example to make this clear. Let's first suppose that x equal to 2 and y equal to 7. As you know, any decimal number can be represented in binary system. Here is the binary representation of 2 and here is the binary representation of 7. And we will apply bitwise AND operation between these two binary numbers. Now, let's compute the result. 0 and 1 equal to 0. 1 and 1 equal to 1. 0 and 1 equal to 0. 0 and 0 equal to 0. 0 and 0 equal to 0, etc. Now, here's the result of bitwise AND function in binary representation, which is equal to 2 in decimal. Now let's go to bitwise OR function. Let's say x equal to 2 and y equal to 7. Now let's apply bitwise OR function on these two binary numbers. 0 or 0, the result equal to 1. 1 or 1, the result equal to 1. 0 or 1, the result equal to 1. 0 or 0 equal to 0. 0 or 0 equal to 0, etc. Here's the result of bitwise OR function in binary representation, which is equal to 7 in decimal system. Now let's go to bitwise XOR function. Let's say x equal to 2. Y equal to 7. Here is the binary representation of 2 and binary representation of 7. And we will apply XOR on these two binary numbers. So 0 XOR 1, the result equal to 1. 1 XOR 1, the result equal to 0. 0 XOR 1, the result equal to 1. 0 XOR 0, the result equal to 0. 0 XOR 0, the result equal to 0, etc. Now here is the output of bitwise XOR function in binary representation, which is equal to 5 in decimal system. Now, as we said before, bitwise AND has three arguments, which is the same case in bitwise OR and bitwise XOR. The first argument, x, it is a tensor. The type of this tensor must be one of the following types: integer 8, integer 16-bit, integer 32-bit, integer 64, unsigned integer 8, unsigned integer 16, unsigned integer 32, unsigned integer 64. And the second argument, y, it is tensor as well. And the tensor y must have the same type as tensor x. Now let's go to invert function. This function will take only one argument, which is x argument. It is just a tensor and the data type of this tensor must be one of these data types that we said before. Let's say x equal to this binary number 10101010. If we apply this function, invert function, on this binary number, the result is equal to 01010101. So this function invert or flip each bit in this binary number. Now let's go to left shift function. This function has three arguments, x, y, and name. X is just a tensor and the data type of this tensor must be one of these data types that we said before. And y is a tensor as well and must have the same type as x. Let's say x equal to 7 and y equal to 2. And here is the binary representation of x as you can see here, when we apply left shift function on this binary number, all these bits inside this binary number will be shifted to the left by y, which in this case 2. And here is the result of left shift function, which is equal to 28 in decimal system. Now let's go to right shift function. This function has 3 arguments, x, y, and name. And as we said before, x is a tensor with data type equal to one of these data types that we said before, and y is a tensor must have the same type as x. When we apply right shift function on this binary number, all these bits inside this binary number will be shifted to the right by y, which in this case 2. And the result of right shift function is here, which in decimal equal to 1. The last thing you should know that the output of all these functions, bitwise AND, bitwise OR, bitwise XOR, invert, left shift, right shift, must have the same type as x. Now let's go put all what we learned in practice. As you can see here, I will use this function, binary digits function, to convert any decimal number to its binary representation. First of all, let's import TensorFlow. After that, we will import Bitwise and from Bitwise module. Now let's make tensor x. X equal to TensorFlow dot constant, open parentheses, open square brackets, and inside these square brackets, I will put the elements of tensor x. Let's put just one element now. Let's say 7, and the data type of this tensor equal to TensorFlow dot integer 8-bit. Now let's create y tensor. Y equal to TensorFlow dot constant, open parentheses, open square brackets, and here we will put just one element, let's say 2. And the data type of y tensor equal to TensorFlow dot integer 8-bits. Now let's apply bitwise and function on these two tensors. So results equal to bitwise and function, open parentheses. Now let's put x argument and y argument. After that, we will print the result of this function. As you can see here, the output of bitwise and function, it is just a tensor with the type same as x, which is integer 8 bits. And here is one element in this tensor, which is 2, which is produced by applying AND operation on these two numbers, 7 and 2. Now let's import bitwise OR function and use it here on these two numbers, 7 and 2. Let's see the result. As you can see here, the result is tensor as well, with one element inside it, which is 7, and the data type of this tensor like the data type of tensor x, which is integer 8 bits. Now let's import XOR function and apply it here and see what is the result. As you can see here, the result is a tensor. There is one element in this tensor, which is 5, and the data type of this tensor is integer 8-bit, like data type in tensor x. Now let's import invert function. As we said before, this function has just one argument, which is x. So let's type invert, open parentheses, and put only x here. and let's show the result. Here's the result, as you can see here, in decimal. Let's see the binary representation of the input x and the result. So now I'm gonna use binary digits function, and here we will put the element inside tensor x, which is 7, and the number of bits, which is 8, because the data type is integer 8 bits. Now let's show the result. As you can see here, this is the binary representation of 7. Now let's see the binary representation of -8. This is the binary representation of -8. And as you can see here, invert function flip all bits in the input and produce this binary number. Now let's import left shift function. Left underscore shift, and we will call it here and type x and y. So in this case, the binary representation of 7 will be shifted to the right by 2. Now let's see the results. Here is the result, which is a tensor with one element in it, which is 28, as we said before. And the data type of this tensor, same as x, which is integer 8-bit. Now let's import right shift function and see the result. Here is the output of right shift function, which is a tensor, and the data type of this tensor, integer 8-bit. Same as tensor x. So now we learned all functions inside Bitwise module. Thanks for watching.